make sure that you know the three parts of the atom and where they're located. Protons are located in the nucleus and have a positive charge. Electrons are located in the electron cloud and have a negative charge. And neutrons are located in the nucleus and have a neutral charge. The atomic number, which is the top number, represents the number of protons in an element, while the mass number is the number of protons and neutrons. So on a chemical symbol, you have the mass number over the atomic number. So 23 over 11 Na is sodium with a mass of 23 and an atomic number of 11. If you're writing the chemical symbol for magnesium 23, the 23 represents the mass, so that goes on top. And to find the atomic number, you need to look on the periodic table, which it's 12. An isotope is an atom that contains the same number of protons, but a different number of neutrons. So if you have carbon 12 and carbon 14, how many protons does carbon 12 have? It has to have 6 or it wouldn't be carbon. To get neutrons, it's mass minus protons. Carbon 14 also has 6 protons, so they're the same, but notice the neutrons are different, and that's what makes the masses different. Atoms are neutral due to equal protons and electrons. Ions have charges. Cations have positive charges while anions have negative charges. So cations, to get a positive charge, have to lose electrons, while anions have to gain electrons to get a negative charge. Go ahead and try these three on your own. Restart the video when you have your answers. First one, calcium has a +2 charge. Calcium always has 20 protons, which means we have more protons to electrons. We have to have 2 more protons than electrons, so that gives us 18 electrons. To find out how many protons iron has, you just have to look at the atomic number of iron, which is 26. And finally, we need to see how many protons fluorine has, and it has 9. It has a negative charge, which means it has more electrons to protons, which means it must have 10 electrons. Go ahead and pause the video and try this one on your own. You're trying to find the total protons in 2 molecules of C20H30O. Well, each carbon has 6 protons, but we have 20 of them. Each hydrogen has 1, but we have 30 of them. And each oxygen has 8, and we have 1 of those. So altogether, that gives us 158. But we want to know in 2 molecules. So we need to multiply that by 2, which gives us B as in boy, or 316 protons. So make sure you read carefully. Make sure you know the difference between ionic and covalent bonds. We'll get more into bonding later in the year, but for right now, you just need to know that ionic, one loses, one gains, so that's going to be between a metal and a nonmetal. And in covalent, they're just sharing electrons, so between only nonmetals. If you have an acid and you need to name it, you need to first ask yourself, well, does it start with hydrogen? If so, it's an acid. If not, you're going to use the other flow chart. Does it have a polyatomic ion in it? If not, it's a binary acid, and so you just have 2 elements. You write the prefix hydro, change the end of the nonmetal to ic and add the word acid. So HCl would be hydrochloric acid. If it does have a polyatomic ion, if it ends in 8, it goes to ic. So H2SO4 is sulfuric acid. Ite goes to OUS, and you add the word acid. So H2SO3 is sulfurous acid. Pause the video and try writing the names and formulas for these acids on your own. Starts with an H, so it's an acid. NO3 is nitrate, so 8 goes to ic, making it nitric acid. The second one starts with hydrogen, so it's an acid. F in a compound is fluoride, and ide goes to hydroic. So we get hydrofluoric acid. H2C2O4 starts with hydrogen, so it's an acid. C2O4 is oxalate. Make sure that you know those polyatomic ions for that first day. So that's oxalic acid. On 4, we're having hydrosulfuric acid. So hydro and it came from IDE, so that's sulfide. Sulfide has a -2 charge, so that's H2S. Chromic acid came from chromate, which is CrO4 with a -2, so we need 2 hydrogens in front. On the other side, if it's not an acid, then you need to ask yourself, well, does it start with a nonmetal? If so, you have to use the prefixes. You name the first nonmetal using the prefix to indicate the number of atoms. Then the second nonmetal with prefixes to indicate the number of atoms. So CO2 would be carbon dioxide. Does it start with a transition metal? If so, name the transition metal, write the name of the nonmetal with ide, and you have to use Roman numerals to tell the charge of the metal. Remember, if it's not group 1A, 2A, silver, zinc, cadmium, or aluminum, you have to use Roman numerals. And if it doesn't start with a transition metal, then that means you know the charge, so you just name the metal and nonmetal with ide. So CaS would just be calcium sulfide. So pause the video and try naming these on your own. The first one doesn't start with hydrogen, it doesn't start with a nonmetal, it doesn't start with a transition metal, so you're just going to name it as is. So sodium fluoride. The second one starts with a nonmetal, so you've got to use prefixes. So nitrogen dioxide. The third one starts with hydrogen, so it's an acid. Sulfate turns to ic, making it sulfuric acid. The fourth one doesn't start with hydrogen, doesn't start with a nonmetal, and we know the charge of lithium, so it's just lithium phosphate. The fifth one, again, not a hydrogen, not a nonmetal, not a transition metal. We know it, so it's just magnesium oxide. And F is not a hydrogen, doesn't start with a nonmetal, but it does start with copper, which is a transition metal. Oxygen's a -2, which means copper must be a +2. So that's copper 2 oxide, the 2 being the charge on copper. Go ahead and pause the video and try writing the formulas for these. Iron is Fe. That 3 is the charge on iron. Chlorine is a -1, so together that's FeCl3. Calcium is a +2. Sulfite is SO3 with a -2 charge. So it's just CaSO3. Sulfur hexafluoride has prefixes. There's not a prefix in front of sulfur, so that's 1 sulfur, hexa 6, so 6 fluorine. Hydrofluoric acid, hydro and ic, came from ide, so that's fluorine. Fluorine has a -1 charge, so that's just HF. Zinc chloride, you need to know the charge of zinc, and that's a +2. You should also know that silver is always a +1, aluminum's a +3, and cadmium was a +2. So, going back to the problem, zinc is a +2. We don't need Roman numerals because we know the charge of zinc. So it's zinc +2, chlorine -1, which is ZnCl2.